Good evening and welcome to my video about adding and subtracting fractions. Uh, well, rational expressions, but basically the same idea. Let me try my best to run through this as quick as possible. Here we go. Now, I'll just do this part first. Oh, not that part, but this part. Understand when you have to add fractions, then that means that your denominator has to be the same. That's what this whole part right here is about. So notice here, as long as the denominator is the same, we can add fractions. As long as the denominator is the same, we can subtract fractions. But that's not the issue. That's easy when all we have to do is just with the same denominator. However, the problem is when the denominator is not the same. You have to find what's called the least common denominator, just like with fractions. So if you're just trying to find the least common denominator with fractions, all you're doing is just find the least common multiple of the denominators. And then you are expressing each fraction as an equivalent fraction. So really you're multiplying by what I like to call some kind of 1. And you'll see what I'm talking about in a second. For example, if we're trying to add these fractions together. If we're trying to add these fractions together, we can't because the denominators are not the same. So in order to make them the same, we want to multiply each one of these fractions by some kind of 1, something equivalent to 1, something that equals 1. In this case right here, to make them the same, I know I'm going to have to multiply the bottom by 4. Therefore, I have to multiply the top by 4. Notice that this equals 1. That's what I mean by some kind of 1. Over here, you got to multiply the bottom by 7. And you got to multiply the top by 7. So if that's the case, you're talking about 21 over 28 plus 20 over 28. In other words, this is going to be 41 over 28. So really, all you're doing is LCD. We all remember how to do it when we're adding fractions that look like that. However, when we start using variables, hopefully the same idea can come across to us. If we can make these denominators the same, then we can add the fractions. However, it's hard to see, with this right here, it's hard to see what our lowest common denominator is going to be. So what I'll do is off here, with 6a squared and 2ab, I'm going to try and find the lowest common multiple between these. So here, if I break 6a squared all the way up, that'll be 3 times 2 times a, right? And if I break up 2ab, it's just going to be 2 times a times b. Now, in order to make those denominators exactly the same, it's really important to see what I have to add on to both of them. Now, all you're doing is whatever this denominator doesn't have, but this one does, you give that to this denominator. For example, with 2ab, since this has 2 a's, this needs another a. Since this one has a 3 up here, this one needs a 3 as well. Same thing up here. This one, out of all of these, this does not have a b. So you see what we just tacked onto each one. So what that means is this top one now is going to become 6a squared b. And notice this one is also going to be 6a squared b. So now they're the same. So now we understand what we had to multiply by both of them to get what we needed. For 6a squared, we just had to multiply this side by b. And whatever I do to the bottom, I have to do to the top, right? Over here, I multiplied by 3a. And whatever I do to the bottom, I do to the top. So now that means that my new fraction should come out looking like b over 6a squared b plus 3a over 6a squared b. Now I can add those together to end up with 3a plus b over 6a squared b. So that's what happens when we add them. Now the thing is, with problems like this, I'll just do one of them. It's the same idea, but remember, we're trying to get lowest common denominator. My advice to you is to factor first. if you factor first, it shouldn't be that bad. So this one is 3 over x, let's see, x plus 3, x minus 2. And that's going to be minus 2 over x minus 1, x minus 2. So then you're thinking about what can you multiply each by just so you can get a common denominator, or least common denominator. Here, this one doesn't have an x times 3 on it, right? An x plus 3 on it. So whatever we do to the bottom, we do to the top. So here is multiplying both of those by x plus 3. And over here, we pretty much have to do the same thing. You're multiplying this by x minus 1. And you're multiplying the top by x minus 1. Since you're going about that, since you're doing that, your new fraction, let me change my pen. Your new fraction now is going to be 3 times x minus 1 over x plus 3, x minus 2, x minus 1, minus 2 over, make it nice and long, x plus 3, x minus 2, and x minus 1. Oh, I'm sorry, this is going to be 2 times x plus 3 right here. So since that's happening, then I know that what I'm going to end up with is in one fraction, you have 3x minus 3. All I did was distribute this 3 into that binomial, minus 2x minus 6, because this negative has to go along with that 2 when you distribute. And that's all over x plus 3, x minus 2, x minus 1. So when we our final product we should have in the top should be x minus 9. In the bottom you still have that big old denominator, which you can keep just like that. You don't have to multiply that back together. So that's what we mean by our least common denominator thing. It's not that bad. It'll probably just take a little getting used to. I'll do one more and we can go from there. Let's actually do this one. Well, that gives you an idea. I'll start this one and I'll let you guys finish it. If I'm factoring this, that's x plus 1 over x plus 2 squared. That's what that looks like. Minus 6 over x plus 2, x minus 2. So notice what's missing. From here, what's missing is over here, this needs an x minus 2. And over here, this needs an x plus 2. So that means that our final product, well, not our final product, but when we put this all back together, in the top here you have x plus 1 times x minus 2, whatever that might be, minus 6 times x plus 2. And all of that is going to be over x plus 2 squared times x minus 2. And after that, you should be able to mash all that together. If it can be simplified, please make sure that you simplify it once you do all the adding and subtracting, and you should be good. So for the most part, that is all you need for adding and subtracting rational expressions.